In this speedrun, we're using Spark Structured Streaming with Databricks Apps to both process and monitor a fleet of delivery drivers. I'm the CEO of Casper's Kitchen, a nationwide ghost kitchen provider for restaurants. Our locations are optimized to produce and hand off food orders from the restaurants to third-party delivery services. Now, our restaurants really don't like paying high commissions for these deliveries, so Casper's is now providing them with our own in-house delivery fleet. To support this fleet, we need two things. First, we need to process all the events the fleet produces, like picking up the order, tracking locations, and confirming that the order is actually delivered. We'll use a delta table to land our events, structure streaming to process and aggregate them, and another delta table to store the complete trips. Second, we need a custom interface to show us all the delivery events being aggregated in the stream. For this, we'll use Databricks Apps to host a custom application and have the application query the stream using the new State Reader API. Let's get started. First, we need our initial landing table for the events produced by the drivers and the final table for the complete trips. This is a proof of concept, so we're ignoring things like types for simplicity. Second, we define our stream to read from the events table, aggregate the trip status updates using the order ID key, and flush the complete trip records to the final drives table, only when the delivery event for a given order comes in. Let's kick this off by writing our first event to the event table, simulating a pickup event for order 4. Using the State Reader API to read the state of the live stream, we can see that the key order 4 is currently in the streaming operator. We can also confirm that our final drives table remains empty. Let's add an on-the-way event and observe that our state is correctly aggregating. And finally, let's kick off the delivered event that flushes the aggregate state and writes our final trip history for order 4 to the drives table. Now that we've demonstrated the entire lifecycle of the delivery, let's see how to use a Databricks Apps to create a custom display for this data. Here in our apps list, we see the Driver Monitor app and see that it's been started successfully. The app consists of two main components. First, we use a thread to query the stream state using the State Reader API and the Command Execution API. Second, we use server-side events to return the data to the client. The client then loops through the event data and maps it using Leaflet, a popular JavaScript mapping library. Here's the live app. Let's go back to our notebook and simulate a new pickup event and observe it coming through on the map. We can also demonstrate how the stream and architecture is fault tolerant by stopping our stream, queuing up the next on-the-way event, and restarting the stream. Back on the map, we can see that the updates are robust across restarts and failures. Let's fire the last event and see that the map clears. It's that easy.